One of the problems that we've commonly heard people want to apply Sphinx for is budget optimization. And here we'll show an example specifically in the context of advertising. So we'll ask Sphinx to go look at our historical ad data and build us a model and optimize for how I could spend, let's say, $200,000 over a 60-day campaign. Let's say we want to do multiple campaigns, one campaign targeted at each age group, and then optimize over the choice of how much to allocate to each age group. To visualize this, let's look at obviously the optimal allocation of dollars to maximize engagement. And also let's visualize a bar graph with error bars, of course, of how much engagement we expect to have with this optimal allocation, as well as what we would have gotten had we just followed, let's say, equal spread and historical averages as a baseline. We'll fire this off to Sphinx, and it will start by, of course, exploring the database. I have told it where the database is, but the actual contents it'll need to learn itself, looking at various pragmas, looking at samples of data, and then building understanding of what the relationships of that data are. And once it's done that, it can start to build out the fields it needs, doing various joins and mapping various fields to each other, including what does engagement mean according to a reasonable definition. Of course, you can see here it's guarding against bad rows, building tables that deduplicate campaigns, remove null rows, etc. And now with that done, we can finally move to modeling. So a modeling data frame is prepared, and Sphinx will almost certainly, before doing any modeling, do some EDA to understand the data distribution. And having done that, you can see that the response curves of dollars versus engagement are not that clean. They're actually extremely noisy, and that makes me think that we may not be able to have incredibly tight error bars. But that said, it does seem like all activity for these campaigns does fit into some tight range, so we should be able to have a prediction that is workable and at least reasonable to use for this experiment. And now we can move to the optimization itself, since we fit a linear model for a linear model in the log space, so a logarithmic model for the response curves. It seems like Sphinx is opting for a relatively simple brute force algorithm to optimize here, but of course we could give it instructions, or if the data set were large enough, it would optimize on its own. And here we found what it claims to be the optimal allocation at last. 25 to 34, 35 to 44, both getting a reasonable cut of the spend, but almost nothing being allocated to universal campaigns or to 18 to 24, the youngest age bracket that this company seems to cover. Historically, actually, that seems to have been one of the larger buckets, and there's a lot of just general advertising to all ages. But here, of course, the model is suggesting that we cut some of those categories and reallocate to a 55-45 split. Let's now see what Sphinx thinks is the best way to visualize this. So it will go and use Bootstrap to come up with error bars, which I think is a reasonable framework here, in order to draw some samples and see how the distribution of outcomes looks. Obviously, that will lead to similar outcomes for all three cases, but will allow us to quantify the distributions. And now we can generate some bars which indicate, okay, we're getting around 40,000 impressions in the optimal allocation, with reasonably tight error actually, as well as getting around 37,000 with like minor variation between our historical and equal weight allocation. Certainly getting an 8% increase in the success of an ad campaign at the same budget is quite a large win, and this is a type of outcome that can be achieved by leveraging Sphinx in the data with around 4 minutes of total runtime, both in terms of giving Sphinx information and letting it run through the analysis.